Okay, so the idea is that we are going to really take a look here at three-dimensional space and how to create a figure from something called cross-sections. And I know we talked about it in class a little bit, where we have talked about this idea of you having a region and then you're stacking shapes inside of that region to create a very interesting solid. And what we came away with from class today is that in order to get the, let me skip to the right thing, in order to actually figure out what volume might be, we need to take the integral of the area of the cross section. And the reason I'm not writing an actual formula right here is because this changes depending on what is the shape of your cross section. Is it a square? Is it a triangle? Is it a semicircle? I mean, there's all different things it could be. And whatever that is, this is what's going to go behind your integrand. Now, your A and your B up to this point are just going to be your x values that bound your region. We got a dx back here to let us know we're integrating with respect to x, so that if you see a picture, you can just look at where it begins and where it ends on the x-axis, and that's what's going there. If you can't see it with your own eyes on the picture, if it's two different curves, sometimes you have to set them equal to each other and solve, okay? Before we do examples or more examples, I'd first want to just help you with some shortcuts, okay? These are some popular things that show up, and we already looked at a square in class today, but what if we were looking at semicircles being stacked on a region? There's a formula for area of a semicircle, and we could put it into our integrand, and then we can simplify and all this, but in the end, we will get a special formula for this and a special coefficient. So if you are stacking semicircles, you can use the coefficient pi over 8 from A to B of your r squared, or what I'm calling here as your s squared, okay? So this is the same thing like we did in class with the squares when we just squared the side, but now we're going to multiply that by pi over 8 if we're stacking semicircles. And we'll do an example in a second. Equilateral triangles, your special coefficient is the square root of 3 over 4. Same thing of s squared. And these are, we're still in dx land right now. And so those are two formulas that I would memorize, just like in class today when we had the square. Feel free to just remember that the area of a square is side squared, and then you'll always be able to integrate this one as well. Now, if you don't remember, what is this s? S. I keep writing s in all these formulas, but remember that s is just the distance from the top to the bottom of the region. And your region is going to change shape. The region's what you're building on top of, and this could always change. So, for instance, if you have a picture and maybe we're doing like x squared plus 2, let's say, and maybe we are looking at maybe we're also looking at like y equals 3x or something like that, okay? If these are the two curves and you're building on the region between them, and I'll just shade in right here, and we're stacking on top of that, you just really want to pay attention to where is the top of the region and where is the bottom of the region, and if you take the difference, that is your s. So for this one, it would just be the top curve, which is the parabola, minus the line below it, which is just 3x. That would be your s that you would be using in all three of these other formulas, okay? And this would help you end up, finding the volume, okay? And so remember, these are finding a volume, every single one of those, okay? Now this last one I saved, because if you're doing a rectangle, there's not just one formula, but you have to actually read it out, because if you're doing a rectangle whose height is 3 times the length of the base, well, the base, guys, is the S, so it would be this same top minus bottom concept. But in a problem like this, if we're doing area and we know that the base is S and then the height is 3 times that, well, the area of a rectangle is just length times width. So if I multiply these together, the width across the bottom is S times the height is 3 times that distance. So it might look something like this, okay? S times 3S. And so that would be how you go about doing these. So we'll do some examples on the next page. So here's an example. Find the volume of the solid formed by laying semicircles perpendicular to the x-axis onto the region formed by the x-axis and the graph y equals negative x minus 3 squared plus 4. So here's a graph of the parabola in question, and we need to bound it by the region formed by this and the x-axis. So it's talking about all of this, and we're laying a bunch of semicircles this way, up and down. And I know that because of this terminology, perpendicular to the x-axis. So we're laying them up and down. So the first thing that I would probably do is go ahead and figure out the formula we need to use. So if we're doing volume for semicircles, that was on the other page, and it is this formula. And if we know this formula, now all that we have to do is fill in the A, the B, and the S. I think the S is going to be the easiest thing, because S is just the distance from the top of the region to the bottom of the region. And that just means this equation minus this equation. And if you're at the axis, that is an equation y equals 0. Okay, that's just 0. So A to B, and so my S is going to be the top equation minus 0, and it's going to be all of that squared, okay? And now the only thing left to do is to find your A and your B. Well, A and B are your left and right, where this starts and where this stops. So it's right here and it's right here. And if you can't tell from the graph where that is, we could always find that by setting this equal to 0 and solving, and that's going to help us figure out those 2 points. So as a real quick off to the side, we could find our points of intersection. So I'm going to have, let me move the 4 to the other side first, and they're both negative, so let's make them both positive. Now I'm trying to solve for x, so I need to get rid of the squared. So let me square root both sides. And don't forget, when you square root, you need to do plus or minus. So now I've got x minus 3 equals plus or minus 2, which means that x is either, let me add this 3 over, x is either 5 or 1. So this one must be 1, this one must be 5. I'll put them on my integrand, and now I would pick up a calculator and just go to town. Math 9, type it all in. You can type it even with the coefficient all at the same time, and you should be able to work through it.